Okay, like I was saying, what we want to do now is apply what we've been learning. So here we have a real-world application. We have some corporation which pays a bonus if you sell, make enough sales of whatever it is that the company is selling. Let's pretend it's widgets.
What's that?
What's a widget? It's a made-up product for use in school.
Oh, okay. It's a Dr. Seuss product. It's made with moths.
Anyway, so the question says that if you make 10 sales the first week and then improve your sales by 2 each week, at the end of 50 weeks you will get a $10,000 bonus. So what we need to do is two things. We have two questions. How many sales did the salesperson make in week 50? And then what's the total number of sales? So since we're being asked two separate questions, it stands to reason that we're going to need two separate formulas. So we're going to use our what's the value of the last term formula. And we're going to use our what's the sum formula. And in order to use this formula, we need to know n. We need to know what's the value of the last term. Okay, so we know what n is. We know how many terms there are in the series. It tells us. In fact, everything we need to know about the problem is in the problem. So it tells us the number of terms in the series. It's 50 because it tells us it's 50 weeks. It tells us the number of terms in the first week. How many sales did the person make in the first week? 10. We know what n is. What? What did you say? What's n?
Me? That's it.
N is 50. So it's 50 minus 1. And what's the common difference? What's the difference in sales each week that we have to achieve? 2. So you can see all the numbers are provided to us. Now we just have to solve. So what is a sub 50? Well, 50 minus 1 is what?
49.
So I get 49 times 2. 49 times 2 is
98.
98. 98 plus 10 is 108. So that's the number of sales in week 50. Number of sales in. I would remind you that on a test, in a word problem, you must indicate the units. Here the units are sales. So you must make some sort of notation of what 108 represents. How? Alright, it says here that the person makes 10 sales the first week and then improves their sales numbers by 2 each week thereafter. So it tells you. Alright, so now we can apply this formula. We want to know what is the sum of my 50 terms. 50 divided by 2. My first term again is 10. Now we know the last term. The last term is 108. 50 divided by 2 is 25. 10 plus 108, 118. 25 times 118. Did anybody do that? 2950 is the number of total sales. And that, as they say, is that. There's the answer to, there's two answers to the question. Two questions, two answers. Very
So your first answer is how much they made in week 50, and then this is total in all 50 weeks.
Okay, does anybody have any questions? Is there anybody not done copying yet? Okay.
Pencil sharpened in an exact way.
Okay. All right, the last thing we're going.
What was the final number?
1725. All right, the last thing we're going to talk about is this Greek letter. This Greek letter is the Greek letter.
Oh, okay. The limit does not exist.
Excuse me, that's calculus.
Oh.
Greek letter sigma,
Oh, geez.
and we use the Greek letter sigma to indicate what is called summation notation. Summation notation. Summation notation has three parts to it. It has the upper limit, which we write on top of the sigma, the lower limit, which goes at the bottom, and then your explicit formula, which goes on the side. We'll get to this in a second, although it's pretty obvious what it says. The number of terms is the upper limit minus the lower limit plus 1. Now here I have an example.
Wait, so is this if you graph, if you like try to graph the explicit formula?
No, you're not graphing it. There's no graphing.
You like, it'll create that shape.
No. It says Greek letter, sigma. It means sum, I believe.
What's it called?
Sigma. Alright, so
Have it alpha.
alright, so I put an example up on the board. The upper limit is not the values of the terms, but the number of terms. Okay? So how many terms do I have in this series? If I'm counting by tens from 10 to 500, how many tens are there from 10 to, how many groups of 10 are there from 10 to 500? There's 50. So my upper limit is 50. Again, it's not the value, it's the number of values. So there's 50 values. The lower limit is, what's the lower limit? What's the lowest term number? You start counting with term number.
10.
No.
What?
We start counting with 1. So the way we don't just write 1, we write that n equals 1. And that's going to be the case for most of the ones that we work on. Every so often, they throw a curve at you and change what n equals. In fact, the example that the book uses to explain this has n equals 3. Okay, now, if we were to sit and figure out the explicit formula, what we would get is this. 510 minus 10n. So that would be your speed. What we're going to do is, you'll see in the example we're going to do is, we're going to figure out what this is. We're going to figure out the explicit formula.
Why 510?
That's just how it works.
You add 10.
I don't know. I have to sit and figure it out. I'm just copying from the book right now.
Oh.
What?
It's always
When you say it's these numbers are going to change from problem to problem. What goes here is going to stay the same. The upper limit always goes on top. The lower limit goes on the bottom. The explicit formula goes here on the right. And again, to find the number of terms, it's simply the upper limit minus the lower limit, and then add 1 back.
What's the explicit one?
What is the explicit formula?
Yeah.
It's what we use to find the value of terms. All right, so let's do one. Okay, so here's my series, and what we want to do is write this series in summation notation. Okay, so the first, since we know we're going to need the explicit formula, we know we're going to need a sub n is equal to a sub 1 plus n minus 1 times d. we might as well indicate what that information is. Write down the relevant information. We know our first term. Our first term is going to be what? 7. And the common difference is 11 minus 7. 4. Okay, so now we're going to find the explicit formula, but we're not going to solve. We're just going to set it up. So we're going to leave this as a sub n. Our first term we saw was 7 plus n minus 1, and then my common difference is 4. So that's the importance of just recognizing what the information is. Do you have to separately write it down? Of course not. But again, when you're doing these for me, in other words on a test, the more you write down, the more credit I can find for you. The clearer you are, the easier you make it for me to read the problem, the easier it is for me to find points. Alright, so now we're going to distribute. So I get 7 plus 4n minus 4. Combine my like terms, I get 4n plus 3. So that's my explicit formula. A sub n is equal to 4n plus 3. Now remember, the reason why I'm not solving this is because I'm not being asked to find the sum. I don't care at the moment how many terms there are. We are going to figure out how many terms there are. In fact, that's the next step.
Wait, no, I was not back. Thank you.
Okay, so now we want to find the number of terms. So we're going to start with a sub n is equal to 4n plus 3. We know the value of our last term. If you remember, it was 207. So it's 4n plus 3. We're going to solve for n. I get that 4n is equal to 204. Divide both sides by 4. And I get that n is equal to 51. So the number of terms is 51. I now have the 3 pieces of information I need to fill in my summation notation. The upper limit, this is the upper limit, the number of terms. So that's 51. The lower limit, our first term was 1. So n equals 1. Now, the value of our first term wasn't 1, but we started by counting 1. So n equals 1. And the explicit formula, that's what we figured out up here. So my explicit formula is 4n plus 3.
Why do you have to write the giant E?
Because it's a Greek letter sigma. That's the summation notation.
Oh, okay.
Oh, Jillian.
And that's our answer.
No.
Yes, Joy.
S plus 4n